Welcome to episode 15 of the Welding Codex. This is a podcast for those who want to learn more about the technical side of welding. Welding codes, heat treatment, welding defects, metallurgy, and all the subjects that your high school welding instructor didn't have time to cover. In this episode, welding engineers and CWIs Peter Kinney and Garry continue their review of AWS D1.1 Structural Welding Code Steel. This episode covers another portion of Clause 6. We're going to go into Part C, more in-depth acceptance criteria. Clause 6, inspection, is a cornerstone of the AWS D1.1 code, and as such, it has a lot of material to cover, so it will take us a few episodes to cover the material. Anyhow, thanks for joining us. Note, this is going to cover 2015 and 2020 during the course of the episode, so we bounce back and forth. Before we get going, time for the advertisements. If you are on a budget and are looking for an affordable online training course for the AWS CWI Certified Weld Inspector exam, visit train-eng.com. 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 And check out the online courses for Part A, General Knowledge, and Part B, the Hands-On Inspection. Train-eng.com also has some buffet-style options on the CWI review course. If you're strong in some subjects and not as strong in others, or if you only wanted to take metallurgy, go in there. For a few dollars, you can take that portion of the online course. That's an option. We have it set up buffet style. We also have a CWI questions bonanza with about 1,000 questions, I think is the number on there, with only practice questions. If you like what we are doing here on this podcast, feel free to make a PayPal donation on my website, texasweldingengineering.com. Also check out my YouTube channel and the material posted on that platform. We cover a lot of welding-related subjects on that platform. Also, Pete's not going to say this. His audio of what I'm going to say got messed up, so I had to redo it. I couldn't get in touch with him. Anyhow, the views, thoughts, and opinions expressed in the Welding Codex by Peter Kinney are his personal opinions and do not reflect the official policy or positions of the American Welding Society or the AWS D1.1 Structural Steel Committee. Any content provided by our hosts in this podcast are their personal opinions and are not intended to malign any religion, ethnic group, club, organization, company, individual, or anyone or anything. The opinions are just the host's opinions on how their worldview of AWS D1.1 functions. All right, welcome to episode 15 of the Welding Codex. Pete and I are going to dive back into AWS D1.1 structural steel, Clause 6 in 2015, which is inspection, or it's Clause 8 in the 2020 version. We left off on Part C. We were talking about ultrasonic testing, 6.13, ultrasonic testing. And then 6.13.1, acceptance criteria for statically loaded non-tubular connections. You going to run with this one, Pete?
So the portion that we're in is, it's either 6.13 or 8.13, depending on your edition. And we're talking about acceptance criteria. And the first one we're handling right now is a statically loaded non-tubular connections. So we think about this as your shapes, your plates, and in here it'll describe what tables you have to go to for the different kind of like a web to flange, and what your scanning patterns that you need to look at. So this will push you around different areas in the different tables. The next section is 8.13.2, acceptance criteria for cyclically loaded non-tubular connections. So this would be the same type of connections, just we're loading them. The easy classical view of this would be like bridges. That's an easy one. But you can also have dynamic other kinds of structures as well. Big buildings do sway. You have this might be applied to some sort of other part that sees motion of some sort. Maybe it's a pier. Sees a lot of wave loading. And this one breaks it down for tensile. You got to go to table 8.3, and then for compressive you go to 8.2. And then one down farther to 81321 indications. So this is walking us through how we have to rate them with the DB ratings and going through all of this. It'll flip flop you around the different sections of the code, and moving down in the scanning. This will talk about the different kind of scan plans you got to do. All this kind of information would generally be put into a procedure as opposed to someone just saying, hey, I do it by the book. Moving on, Gary, now we got Part D, which is a general NDT procedures.
All right. I was just going to chime in here. And like Pete was saying, in general, you don't use the code for any of this. You use it, but generally what you're going to do is you're going to have your NDE level 3, whoever's writing your procedures, they're going to come in and they're going to pick out the appropriate parts of this code and the acceptance criteria and all of that, and then they're going to put it into a company document. Because like Pete said, you generally don't want to be making the call. You want to just open up a 4, 5, or 6 page document that your company has written that says, okay, this is our NDE procedure for this. This is our PT procedure for these parts. And then it makes it a lot cleaner and easier, and you're not jumping back and forth. You've had somebody that's technically competent write you a procedure, condenses everything down into a really tight package that you can work with.
That's basically it. It simplifies the reading of it and hopefully eliminates some gray areas, because you're going to have like your level 3 writing this. So jumping into these procedures, the first one we'll deal with is RT. And this one is basically saying, hey, when you do RT, you got to be in conformance with Part E of the clause, or Part 10, or Clause 10, Part F. Tubulars is 10. So here it's walking us basically through that. Then we go to UT, and there it pushes us to Part F. MT. So MT, when it drives us to go with Part C of the code, but it also wants it in conformance with ASTM E709. One thing to know about E709 is it's a guide spec. This is not in the 2015 or in the 2020, but in the future, it may have another a replacement for E709, or one to be used in parallel, and that's E3024. That might be a real good document to look for some guidance. It's not required in either of these two editions, but it may be something that would help you a lot. It's a general industry MT. I would personally, was writing a procedure, I would get that document, read through it, and base it off of the code and that, and also familiar yourself with E709. PT, it's referencing us to Part C and also ASTM E165. So those are what we need to look at for those different parts of the book to write your procedure in accordance with and/or these additional ASTM standards. And when you go to these other sections, clauses or parts, you'll also see other ASTM standards being pulled in. Now that we've dealt with the procedural part, now we're going to deal with the people. For people, we're going under ASNT, and we're following their requirements under ASNT, SNT, TC1A. And we have a level 2 or a level 1 working underneath a level 2. You have to have both of these certifications. You have to be done by a level 3, and there's some requirements for that level 3. You have to be certified by ASNT themselves, or you could have successfully passed a written examination described in ASNT TC1A. And this is where, when people will talk about, you have an ASNT level 3 and then you have a corporate level 3. And that's kind of the jargon that's commonly used between these two. And you'll normally, for a company level 3, there'll be usually an outside consultant who is an ASNT level 3 that helps write the written practice and provides the examination to have a company level 3. It's sometimes a way a lot of companies use to get around having to have an ASNT level 3.
All right, I'm going to stop you right there for 1 second and just backtracking. So we're throwing around SNT TC1A. God, I can't talk today. SNT TC1A. That's a mouthful. So you'll see if you're going to be in welding for very long and you're going to cross paths, that's just all that document is it's a recommended practice. It's kind of like a guideline. So it's telling you how to set up your system for non-destructive testing. So if Pete and I start a company making widgets and we want to use eddy current, which doesn't get covered here, but I'm just throwing it out there as a weird one. So if we want to use eddy current, it's going to tell us it's going to help us guide our setup of our testing of our widgets using eddy current. It's going to tell us how many hours we're going to need for our level 1. It's going to tell us how many hours of training we're going to need to get a guy to level 2. It's going to tell us what our level 3 needs. It's not really a code book, but it's a recommended practice that kind of tells you how to set up the rules of Monopoly for your little game that you're going to be playing. And it's an industry standard, but it's just got a whole bunch of information on the different hours required for the different NDT processes, such as, ultrasonic testing is going to take way more hours than if you're going to use PT testing or MT or just strictly visual. So it gives you a recommended number of hours, and kind of so you don't have to stumble through this and set it up from ground zero and reinvent the wheel. They give you some cookie cutter direction that you can follow. I just wanted to throw that out there because a lot of times we get into and throwing these acronyms around. So I'm just backtracking and saying, okay, this is what SNT TC1A is and the general use of it and how it fits in with D11. It's not a code per se. It's just a book that helps you set up the rules to your personal Monopoly.
Correct. It's glad you broke that out, Gary. That's a good call. And another one that you may also hear, depending on what industry you play in, would also be CP 189, which is let's say a stricter version of S&T TC1A.
Okay, so we were back to certification of our level 3.
Yes. So there's one exemption that we probably need to talk about. For personnel performing NDT,
so if you go to 614.6.3, we've got an exemption of QC1 requirements. Personnel performing NDT under the provisions of 614.6 need not be qualified and certified under the provisions of AWS QC1. That's telling us that you can have somebody doing your inspection that doesn't have a CWI. QC1 just lays out all the testing requirements and the levels of certification and endorsements and the functions of certified personnel. That's the document. QC1 is what lines out CWI. So you don't need to be a CWI to do inspections under AWS D1.1. And this is the little caveat in the code that says you don't have to do that. So just letting you know that, okay, you don't have to be a CWI to go in here and for your company and do inspections. You can have other qualifications, but you have to have documentation, everything, but you don't need to be a CWI.
Correct. Yeah, because it's all handled under the AS&T documentation methodology. Moving on to the next one, Gary, it's 615 or 815, extent of testing. So this right here is, they said visual is the only thing addressed in the code as that. It's 100%. Everything else is by contract. Here we have 3 different options. We got full testing, partial testing, and spot testing. Full testing is basically what it says. What do you think full testing is, Gary? Is that like doing 1 out of 5?
Nope. You do the whole meal deal. Full length unless partial or spot testing is specified. So if you're doing full testing, you got to do the full meal deal.
That's right. And partial testing, just like what it says, is you're only doing part of it. Where partial, and then we'll lump in what happens with spot testing too, is you really need to detail out what you mean by partial testing. Partial testing could be 1 out of 5, 50%, 25%, but not only just unless you have unless you have all the same type of weld, you may want to, or actually you need to say, we're doing 50% of the butt welds at over 1 inch in thickness. We're doing 75% of fillet welds, you need to give the contractor guidance to what they are doing. And if I was the contractor and I got a bid that didn't have that in there, I would put in, this is the way I interpret this partial testing, because otherwise that helps prevent a lot of fighting in partial testing. So for both partial and spot, I was on a job representing the owner, and it was kind of like a smokestack kind of looking structure, and and it required spot testing. And I was like, okay, we'll do the intersections where you had your girth weld and your long seam. Well, if you failed one, you had to do two more. And if you failed any of those two, you had to do, it was like, I think it was either 2 or 3 or 4 more. Ended up basically driving it to a full inspection, because at that intersection we just kept popping to where we had to do the whole thing. The contractor probably wouldn't have wanted to chosen that. They would have probably chosen somewhere else, but it was up to the inspection agency to pick it. But you really need to detail out where you're doing them on the engineering side and on the contractor side. It prevents a lot of fighting.
Well, and getting into this, Pete and I both have clocked in significant amounts of time down here in Houston, putting together skids and whatnot, or various components that are going to go subsea. Well, not every weld is the same. You might have a handrail weld is not the same as a main structural weld. So a lot of times you'll see, and Pete was talking about, outlining your welds and giving them a category, like a category A, a category B, a category C. And it'll go through and say, okay, category A, this is all our main line welds. These need 100% visual, and they also need 100% either volumetric or whatever, and then 30% mag particle or something. There's usually some criteria. And then you go to a category B, which is a less critical type of weld, and then it'll have, okay, it needs 100% visual, but you only need to do 50% radiography. And then by the time you get down to, like, let's say a category E, you're just talking about handrail welds. Okay, we're just going to look at those all visual. It's something that it's usually based on, okay, is if this thing breaks, how many guys are going to get killed? Or if this weld breaks, something catastrophic happens, is it going to punch a hole in the ship and sink the ship? And just all kinds of catastrophic stuff. So handrail weld breaks, it's not the end of the world. But if it's a main lifting member or some kind of component like that, yeah, you probably want to hit it with a couple of different variations of non-destructive testing, whatever the engineer calls out. But usually this is in a side document that says, okay, this is A category, this is a B category, this is a C category. So a lot of this stuff you're not generally looking into the code. You have another document that was built off of cherry-picked sections out of the code that are applicable to whatever you're building. And the engineers and the NDE people generally come up with those.
Yeah, good point. And one more thing about partial testing, and this dinged me pretty bad on a job. The partial testing was based off of, it was a percentage of how many welds the welder made. Well, we were running 24 hours a day, 7 days a week, and it was big, heavy, 2-3 inches thick. So I had multiple welders welding on the same part. So I had a whole lot more inspection, because it wasn't one welder made that part. It was 3 folks made that. And to catch the percentages, I was x-raying 3 people's thing instead of just one. So that was a lesson learned there. If you have one person do the whole thing, it definitely simplify your percentages.
Yeah, and you get into this, percentages, and did I shoot enough x-rays of this guy's, the welds he's made. And a lot of this, generally, I haven't had much issue with it on the D11 kind of work, but where you'll run into that is piping, and then, pressure vessel kind of work is where I've seen it, and it gets a little hairier where you got to track, okay, that guy's made 7 welds, I got to shoot 3 of them, or whatever your percentages come out to. Something to keep track of, definitely, and it can definitely bite you in the ass, and it can definitely cost you a lot of money if you have to go back and reshoot things, especially with x-ray. That's a very X-ray and ultrasonic, you can really rack up a bill with those guys pretty quick, shooting things 2 or 3 times.
Exactly. And one last little story on partial testing. There was I was helping the fabricator on this. The specification said 10% of welds. Is that 10% of length or 10% of number? There was basically 2 welds on the job, 40-foot long fillet welds or 6-inch long fillet welds. What are we doing the percentage of? Number or length? That was a little sticky of a situation.
Oh yeah, you can, like I said. Well, I was on a job where the issue came in where we didn't have one point of contact with who was supposed to be shooting the X-rays, and so some things we'd get back, they'd come in and shoot the same thing 3 times because our level 3 was telling them, and then a gal in purchasing was telling them, and a foreman was telling them, and then a guy came in from corporate and he just lost his mind and was like, "Why are you guys doing it this way?" And yeah, there's a lot of ways you can lose money if you don't keep track of this NDE thing. So
exactly. So we're moving over to Part E, radiographic testing. So this section here will start to walk us through how we perform the actual RT of the welds and butt joints. This is what this and the following section, 817 or 617, this is where your procedure would really come from. These sections here. So there are some significant changes between the 2015 and the 2020 code on 816, and what it mainly discusses here is the ASTMs that you're looking for that you'll need to follow. These are the same between the 2 editions as ASTM E94, which is the standard guide for radiographic examination using industrial radiographic film. That's a lot to say. And ASTM E1032, radiographic examination of weldments using industrial X-ray film. One unique curiosity thing that I have found in my days is the number of the ASTM will stay the same. However, the name may actually change a little bit between years. So the changes that I wanted to let folks know about is digital radiography really comes out in the 2020 version as it's an allowed methodology. There's different things you have to follow with what kind of cassettes you're using. Instead of using film, you're using either computed radiography, using like a phosphor plate, which could be also something like as a SIP, or direct radiography using a digital detector array. It really goes into this and how you have to comply with it, how you have to store your film, or excuse me, you don't have film, but you have images, how you have to store images so they can't be doctored up. It goes a really deep dive into that. And I think we may almost do like another podcast just centered around RT and UT in the future, and that would definitely be where we'd go farther into it. 816.2 is variations, and these are things that you can vary when you have agreement between the contractor and the owner. And some of these real quick is like RT fillet welds. That's not really a common thing that's done, or T joints, changing of SORF to film distance. You really need to work through the engineer and the owner on any of these kind of changes that you need to do for maybe some kind of weird situation. Moving down to either 617 or 817, where we got RT procedures. I said this is where we would be taking this information and regurgitating it into a procedure that's readable by an individual in the field. Code language normally is not something that's easily read or followed as a step-by-step recipe type application. So on the first one, 817.1, procedures, here we're talking about both radiographic and digital images. So you have to use a single source of X-ray or gamma, and it walks through how we're going to use our IQIs, either like a hole or a wire. It references a lot of different sections and tables, and this is all the stuff we got to follow to be able to make the shot. Tabs, that's another thing. So here, Gary, where Gary was talking about NDT crews can be expensive. So here's things to make sure that you have done before they show up. Weld tabs, you got to remove them prior to RT unless it's approved by the engineer. So you want to make sure that those are gone, they're cleaned up, they're ground nice and shiny and bright. That's something that you don't want the crew standing around waiting on your guys to make those disappear. Steel backing, it has to be removed, but there's some provisions where it can stay, and you have to grind, and you have to do some grinding. So make sure you understand this on when it's required to be removed and when it's allowed to stay in place. That's another one. You don't want all of a sudden the X-ray crew to show up and you got to remove 20 feet of backing material. I would discuss this if it is allowed to stay. Make sure the RT crew knows that ahead of time. Weld reinforcement. This one's also where it allows a maximum amount on it, and how you have to deal with the IQIs on getting your total thickness. This will walk us through how we have to deal with reinforcement. The type of film, foil screens. You cannot use fluorescent screens. Those are not permitted. So make sure that if you're doing RT or you're contracting it out, that they're not doing that. Another big change is geometric unsharpness. So here there's quite a bit of rewording that occurred, and a little bit change in how the presentation of the equation from the 2015 to the 2020, and that's in 81751. Limitations, how it's presented, is also changed from the 2015 to the 2020. And it's a nice little table that we can follow. And the remaining portion of this is really just walking through how we deal with our procedure, where we put IQIs, our technique for putting the film or overlapping film, making sure that we are handling backscatter, and you got your little letter B on the back on your film, and what the lead B is for backscatter. And if the letter B image appears in the radiograph, it's unacceptable. What that means is whenever you're shooting through, you're getting what's called backscatter. You're getting it reflected off of, let's say, the surface behind it. And you may kind of, I don't want to call it a double image, but it may change the way your image looks. So there's no B for bathroom there.
Yeah, I'm not RT guy at all, so know little bits about it, but haven't done a bunch of it.
Try not to put your head between the camera and the film. That's always a good thing to do.
Yeah, I see that magenta tape, and I run the other direction.
Exactly. That's something that we did kind of skip over with safety requirements. That was up in there. But the crew will show up, and they'll set up a perimeter of a safe distance, and that's something you really got to respect. I know I've heard horror stories of people feeling that because they were the shop foreman or the owner, they could just walk right on through the barrier while shots are getting taken. And gamma or X-ray, I mean, these are things that really can mess you up. So really be careful on the safety side of it.
Well, and they throw up that magenta tape. They throw that tape up there. They're not throwing it up there to keep you out just so they have a nice, quiet work zone. I mean, maybe that has something to do with it, but no, it's an NRC. Hey, we got to keep people from getting in here and getting an unhealthy dose of radiation, be it gamma or X-ray or, whatever. It's to keep you out, and it's your safety. So, and a lot of times, the X-ray crews will come in at night. So, yes. But it gets back to, like Pete was saying, removal of backing or tabs or whatever. A lot of times you might not even have a welder there, and then the X-ray crew comes in. No, we couldn't get to it because this, and this. It wasn't smooth enough. It wasn't ground. We couldn't get our film to it, whatever. We'll be back tomorrow night after you guys fix everything. So
here's your bill.
Yeah, here's your bill. We were here. You didn't have it ready for us. So you can chew through a lot of money.
That's right. Quality of radiographic film and digital image. This is something that's important. So it's very similar between the two. There's been some wordsmithing in there, but in the 2020, It's all radiographic film and digital images shall be free from imperfections and artifacts to the extent that they cannot mask or be confused with the image of any discontinuity in the area of interest in the radiograph. So what this is saying is it's best to have a pristine shot on your film. But if we have a scratch like in the corner where it doesn't really matter, that's allowed. If we have a scratch right down the middle of the weld, what do you think, Gary? Can we use that one?
Nope, not as far as I'm concerned. You need to redo that one. Well, and here's like from the 2015 version, all radiographs shall be free of mechanical, chemical, or other blemishes to the extent that they cannot mask or be confused with the image of any discontinuity in the interest of the radiograph. Such blemishes include but not limited to the following: fogging, processing defects such as streaks, watermarks, or chemical stains, scratches, finger marks, crimps, dirtiness, static marks, smudges, or tears, loss of detail due to poor screen to film contact, false indications due to defective screens or internal faults. So no, if your film's messed up and there's something questionable on there, you either need to reshoot it or reject it. So
exactly. And on that list, the 2020 adds two things. One, it adds to number 5 a SIP or DDAs, and then number 6 is artifacts due to non-functional pixels. So that would be if your monitor that you're inspecting these digital x-rays with, it needs to work. I mean, you can't have like, well, my screen doesn't work there, so you got to size it and move this around. No, you need to have your monitor working properly, and you're also on your. You can't have issues with your film there, with your digital film, where it's not receiving and showing a picture of that location if part of the cassette doesn't work, of the digital cassette.
Right. Okay, so 6.17.11 density limitations. Do we want to cover that?
So we're gonna, like I said, I think in the future we need to do a serious dive where you can hear us for a couple hours just on RT. So we have density limitations on it, that the film has to be a minimum and a maximum, depending on the different kinds, if it's a single exposure, and also with if it's like gamma. All this type of information needs to be included in the procedure, because as I said before, this is not easy reading for a technician out there in the field to try to follow it. The next one, moving down, we have an equation for density, for your radiographic density in the film. Beyond that, we have transitions, and what we mean here by transitions is going from thick to thin, and how we have to look at starting to address this. This is a big change also from on this next one, which is digital image sensitivity to range. The 2015 code, I do not believe, has that at all. So this is a new one that's put in here. If you're dealing with digital, you need to know about this. If you're still using film, you don't. Identification marks. So this is walking us through how do we got to identify the location of where it's taken, and this is by like lead numbers, letters, or both. This needs to be in your procedure. If there's any information like unique information, that would be a good place to put it on here. And normally that what you need to have on here is the contract identification, initials of the RT company, initials of the fabricator or the shop, a date. If this was a weld repair, a lot of people use R1, R2, R3. And for digital informations, that has to be added as text on the processed image for a lot of it. So this is another one that it needs to be identified in your procedure. Edge blocks. This is where when you're dealing with a groove weld. So you've eliminated your runoff tabs and you replace them now with edge blocks. There's thickness ranges that we do use them with, or minimum. So, like I said, another thing handled in our procedure. Linear reference comparators. This is a new 2020 thing, and this is dealing with digital for either your SIPs or your DDAs to make sure that that everything's good there with with the interpretation of the image. So the last thing we're moving on to is 818, examination report and disposition of radiographs. So here, this is for film radiography. How are we looking at these to be able to read them? You need to have a viewer, and normally you have a viewer. I don't know if you ever seen them. They're usually a couple feet long. They got 3 or 4 bulbs in them, really bright, in a dark room. Try not to flash yourself with them. Here's one thing where subdued light. Let's be grown-ups about this one, and make sure that it's dark enough to be able to read the film, because what you're trying to really do is see the contrast of the film with the light behind it. But if you're in a lighted room, you lose some of that the difference in the contrast. Digital radiography. This is also a new part in the 2020 version. This where it's talking about the station monitor. It has to have a certain display resolution and a pixel count that's equal to or greater than the pixel count of the direct imaging plate. So what that basically means is if your image count on your pixel count is 100 on your plate, your monitor needs to be equal to or larger than that. You can't have 100 on the plate and 50 on your monitor. You could have the reverse, 50 on the plate and 100 on your monitor. Reports, you need to include all the different assorted either film, digital images, and normally I will also see some written record of the interpretation of each one of those. There may be some notes on it like scattered porosity, acceptable. What this also helps is if someone comes behind for whatever reason and is like, hey, they didn't see that, or something might have been borderline acceptable. Someone else may come and read, we are human, and measure it a little bigger than they did. But if you flag it out, or you look to bring attention that you actually acknowledged it and looked at it, it helps in a down the road type situation. Got any thoughts on that, Gary? Want to expand on it?
Well, in reports, it's like, here's what it says. It's before a weld subject to the RT by the contractor or owner is accepted, all of the radiographs, including any that show unacceptable quality prior to repair, and a report interpreting them shall be submitted to the verification inspector, to the third party guy. So you're putting together a paperwork package. You can't just throw a stack of radiographs at the third party guy and say, yeah, have at it, man. You dig through this. We'll talk to you later. No, generally you hand them a report and it tells them, okay, I had this one failed, we fixed it. Here's the first radiograph we shot on it. Here's the second radiograph after we repaired it. So usually you put together a grown-up looking report on this that says, all right, we did this and this, or okay, we got a little spot of porosity right here. I looked at it. It's acceptable. We didn't fix it because it's acceptable under this part of the code, or this and this. So you go through and you do as much documentation as possible on this stuff to make it easier for the next guy coming along. So if I'm doing it and then I'm sending it down the road to Pete, I don't want Pete digging through all of this and trying to figure out what's going on. Although I did get sent to a job one time, and all I did was go to a job and dig through radiographs. And I'm not a super radiograph guy, but I went through them all, and there was a bunch where there was like bolts welded up in there and, welding rods. And it was just, and I was like, how did you guys not? I was the owner's engineer on that one, and I didn't confront the NDE guy. I just sent it back through my customer, my client, and I said, well, these are the questions I would ask them. How'd they miss this on this radiograph? Why didn't they find this? Why didn't they find this? And I wrote up a little report and said, these are the things you need to look at. So if you're the NDE person on this, you need to put together reports that are legible, so there's no way it's going to come back on you and somebody's going to question your work, because it does happen. Sometimes somebody will pay, a consultant or whatever, hey man, we're having issues with this. And somebody will come in and, like I said, I'm not a super NDE expert, but I know enough to know that, hey, this is not right. I shouldn't be looking in here and seeing where the welders welded over a welding rod in a V groove, you know what I mean? Just because they wanted to get out of there quicker, or, a bolt in there, or some other material just to make it their weld times quicker.
Exactly. And also a lot of times in the report, you have enough information in there that someone else can repeat your work. You show them the technique that you use. Normally I see there's like a lot of little pictures of how you can put the film in the source, and there's a little check box, and you check which one you used, and you have the time and the distance and type of film, everything that you can that someone else could recreate it if it was called into question.
618.3 record retentions or archiving. A full set of radiographs for weld subject RT by the contractor for the owner, including any that show unacceptable quality prior to the repair, shall be delivered to the owner upon completion of the work. The contractor's obligation to retain the radiographs shall cease upon delivery of this to the owner, or 1 full year after the completion of the contractor's work, provided the owner is given prior written notice.
So Gary, does that mean if I got a storm for a year, can I just like throw them on the table or something, or do I have to really take care of these things?
Yeah, you got to take care of them. You probably want to, if paperwork's not your thing, you probably want to go out there and poach an employee that's used to doing, I would say, medical records or something. Somebody that's got pretty solid game. They don't necessarily have to be a welding person or a construction person, but get yourself a paperwork person, get them some boxes, tell them what they need to do. You put all this stuff in a box or multiple boxes, put it in a climate controlled situation where it's not going to melt or get rained on, or the birds get to it, or the mice or the rats, and you stash it. Upon delivery of the full set to the owner, or a full year after the completion of the contractor's work, provided the owner is given prior written notice. So you hold on to it for a year, 2 years, put it in a archive somewhere, hold on to it. Either that, or you give the owner the full set and you move on about your business.
Exactly. And that's one thing we got to do with film, is it'll fog up, it'll turn nasty if you just leave it in shop type conditions. It needs to be in climate controlled, where it's not going to suffer any of those from that list that we just read a little while earlier about, like fogging and creases and whatnot, and scratches. So we need to take care of it. This is an expansion from the 2020. So we got radiographic digital images. So we need to make sure that these are stored as well, for basically the same purpose, retrieval at a later date. And it walks through all the different information that you're required to have this in for future access.
Yeah, generally this for structural stuff, they're not saying hold on to this stuff for 10 years or, super long periods of time. Okay, you've got it done, stash it for a year, give the owner a copy, and you're done. You're out. So that's probably the easiest route to go, is to give them the full copy and do a turnover and, get a lot of signatures that it was delivered to them, and go on about your business.
Exactly.
All right, that seems like a reasonable place to slice this out, and we'll end this episode and we'll take up the conversation next time. Thanks for listening. Hope this podcast was worth listening to. We're going to have more content coming out. Also, if you want to shoot me an email, gpacex@gmail.com. Give me some ideas, or maybe there's some questions that you'd like me and Pete or me and Joel to answer in regards to welding codes, filler material, or any other material joining question that you might think we have a shot in hell of answering. Anyways, thanks for listening. Take care. Peace out.